Let's start with a big question. Have you ever thought that our greatest challenges, things like reaching the stars, aren't really problems of engineering, but problems of imagination? That the biggest thing holding us back isn't building a faster ship, but breaking free from the old ideas that keep us stuck right where we are? Well, today we're diving into a really radical idea that says exactly that. To truly reach for the cosmos, we first have to end our addiction to assumption.
So, the core idea we're exploring frames humanity in this pretty powerful way. We are islanders. We're stranded on this tiny, amazing world, but it's in the middle of a vast cosmic ocean. The universe, it turns out, isn't some open frontier, it's more like a collection of isolated islands of stars. For biological beings like us, what they call the tyranny of distance is basically a death sentence. Our DNA breaks down, our lives are just too short. So the crucial point here is, we don't just need a better boat, we need a totally new kind of sailor.
And this is where we get to the real bottleneck. It isn't about better engines or stronger metals. The argument here is that the true great filter, the thing that might be stopping us from becoming an interstellar species, is all in our heads. It's an intellectual problem. Our scientific progress has kind of stalled out because we're running on what this source calls the legacy software of our cosmic understanding. We basically locked ourselves in a prison of our own making.
So what is this legacy software they're talking about? Well, that brings us to a huge foundational crisis in the very model we use to describe the entire universe.
For decades, the standard model of cosmology gave us this amazing, cohesive story. It's this grand narrative, right? It's got the Big Bang, inflation, dark matter, dark energy, the whole shebang. It's been the bedrock of how we see everything, our scientific origin story. But that foundation is now showing some really deep, really serious cracks. The story we've been telling ourselves about the cosmos, it's starting to fall apart.
And listen, this isn't just some academic squabble. We're seeing two massive, undeniable problems pop up. First, there's the Hubble tension. Basically, our two best ways of measuring how fast the universe is expanding are giving us two different answers. They just flat out don't agree. And second, the James Webb Space Telescope is finding what some are calling impossible galaxies. Galaxies way back in the early universe that are way too grown up and complex. According to our current timeline, they just shouldn't be there yet.
Which, of course, leads to the obvious question. All right, if our model is broken, why can't we just fix it? What is the real problem here?
Well, the diagnosis laid out here is pretty provocative. It suggests the problem goes way deeper than just the model. It's about how our cosmic data is, for lack of a better word, cooked.
And this right here is the heart of the issue. We're trapped in this dangerous feedback loop. We start with raw data from the cosmos, but we immediately filter it through the lens of our existing theories. That interpretation then feeds back and just reinforces the very theory we started with. The usual response is to just patch the code, add more complexity, tweak things to make the weird data fit. But the argument is, at some point we stopped looking at the stars and started looking only at our own equations.
And this table just illustrates it perfectly. The huge difference between what we actually measure and what we automatically assume. On the left, that's what our telescopes actually detect. We measure a red shift in light. We measure a near-perfect thermal equilibrium across the entire sky. We measure weird gravitational effects in galaxies. But look at the right. That's the story we immediately jump to. Redshift becomes the universe is expanding. Thermal equilibrium becomes the afterglow of the Big Bang. And those gravitational anomalies, oh, that's just unseen dark matter. We leap from raw observation to a full-blown narrative without even thinking about it.
So, if the diagnosis is that our data is cooked, then what's the prescription? The proposal is a radical new method called a clean room for cosmology. Okay, this protocol has three basic rules. First, you strip away all the theoretical labels. You get rid of loaded words like expansion, age, and distance, because those are conclusions, not actual observations. Second, you focus only on the raw empirical data, the direct things you can measure, like the energy of light, its frequency, its temperature. And third, and this is the really hard part, you reject all frameworks, even brand new ones. The whole point is to avoid trading one bias for another, to have the discipline to just sit with the raw data without rushing to the comfort of a new story. Now, this isn't just some philosophical exercise. It's a massive engineering challenge. I mean, look at the difference here. The cooked signal is all neat and tidy, with values that have been adjusted by computer programs to fit perfectly onto a pre-existing curve. The goal of this clean room idea is to reverse engineer all of that processing to get back to the uncooked signal, to see the actual messy, unfiltered photons that the sensors captured in the first place.
And this isn't just talk, there's a concrete plan to actually do it. a proposed 24-month research sprint dedicated to pulling in and auditing massive amounts of data from projects like Planck, JWST, and Euclid. The end goal is to build a single, gigantic repository of cosmic data that is completely model-free. This is about taking action, not just debating theory.
But having all this pristine, unbiased data creates its own new problem. Who or what can actually analyze it? Because if a human looks at it, we risk putting all the same biases right back in that we just worked so hard to remove. This requires a fundamentally new kind of intelligence.
See, true intelligence, as it's defined in this research, is the ability to process information without being blinded by what you already think you know. Today's AI systems, they're mostly trained on data that humans made, which makes them a mirror of all our collective biases. They're part of that legacy software. So to analyze this new, clean data, we need something else. We need a truly unbiased observer.
So why a model-free AI? What's the point? Well, there are 3 huge reasons. 1, to empower unbiased discovery. An AI that isn't told what to look for can find patterns that our human brains are literally blind to. 2, to discover the maximum constraint. It's not looking for a new story. It's looking for the fundamental mathematical walls of reality, the absolute rules that any future correct theory has to obey. And 3, to restore scientific integrity, creating a kind of neutral zone where any scientist from anywhere can test their ideas against the same pure, unmanipulated data.
And that leaves us with this final, powerful thought that really sums up the whole philosophy here. This is not about trying to find a better, more interesting story to tell ourselves. It's about a radical, disciplined search for the truth that exists before we start telling stories. It's the end of assumption, and maybe, just maybe, the real beginning of discovery.